Okay, so what we're going to do today is we're going to actually sort of increase the complexity of our statistics. Yeah, we're getting to the end though, um, and by that I mean we've talked about a single sample t-test, where we look at a sample and we compare it to some known population. That is used occasionally, but much more often, especially in a research situation, what we're going to do is we won't have any like given information. We rarely know population parameters. Um, but what we're going to do is we're going to set up two groups for comparison. It's kind of our basic research design, right? Sometimes people call it a control group and an experimental group. When I teach research methods, I like to tell students they're all of the groups are part of the experiment, so they're all sort of experimental groups. When we talk about control versus an experimental group, usually we're talking about the simplest of experiments. That's what we're going to talk about today, where the two groups vary only along one variable. And so if we see a difference, we can attribute that difference to the only variable that's different between the two groups. Okay, I mean sometimes, I tell people, I mean, here's a simple experiment, right? We're gonna plant a bunch of bean plants and make sure that it's the same pots that we use and so on and so forth, and maybe we'll have 0 milligrams of nitrogen fertilizer in this group, and then maybe we'll have 100 milligrams of nitrogen in this group, and then we'll use a bunch of beans. We don't want to just use one bean plant, and we know that from the central limit theorem, right? I mean, you guys are sophisticated enough to know that. And then we're going to see if there's a difference. Did putting nitrogen in the soil make this group of plants grow better than this group of plants? Okay, and we might measure the height of the plant, or we might measure how many beans are produced, or whatever. And then, so this is kind of the basic experiment, right? You might learn in biology. We're going to use the same basic design to ask all sorts of questions. And the example I'm going to use today is an example of some of my research. And I've published this research. If you're interested in a copy of the article, I can certainly send it to you via email. And so let me explain the experiment. I think it's kind of cool, but it's not going to save the world, but it's an interesting project. So I'm an artist. I mean, it's a hobby, I suppose. I've sold dozens of my works, so it's not really a profession, but I have had some accomplishments, I suppose. I can't quit my day job because making it as an artist is very difficult. But I'm also interested in art, and I used to be on the board of directors for a place called Sculpture Space, which is an organization that hosts modern sculptors from all over the world. And when I would go to the receptions and see some of their artwork, I would sometimes look at the artwork. I'm like, what? I don't get it. That's what a lot of people say about modern art. And then when I listen to the artist sort of explain the piece of art and sort of articulate the intent that they had when they made the art, I look at the art and I'm like, oh, okay, well it's kind of interesting, okay? And other people would have the same experience. And so as a psychologist and as a researcher, I said, I think that I wonder if we can show that this is a general sort of a phenomenon that people, if you listen to the artists talk about the artwork, does that influence how you perceive the piece of art itself? Okay, so I decided to do a fairly simple experiment where I showed people a piece of abstract artwork, and I just asked them how much they liked the artwork. There were actually several questions, but this was one of the questions. How much do you like the artwork? And I used a Likert scale, a 1 to 10 Likert scale, to ask them how much they liked the artwork. For some of my subjects, they just looked at the artwork and told me how much they liked it. Okay? For another group of subjects, they first read a short artist statement. It was about 115 words. They read an artist statement, and then I showed them the artwork, and I asked them, how much do you like the artwork? Okay, so here's our two groups. It's not nitrogen in the soil for bean plant growth, but it still constitutes an experiment, and we're going to collect data that way. So here's a group, no artist statement. Okay, they just see the artwork straight up. And another group, they read the artist statement prior to looking at the artwork. Okay? Now, and I'm going to randomly assign the subjects to the two groups. And if you take research methods, if you're a psych major, you will take research methods. Other professional programs will also probably have you do research methods. The reason I am going to randomly assign to the groups is because I know that not everybody equally likes artwork or dislikes artwork, and so I'm going to randomly assign to the two groups. I'm assuming that there might be a person in this group that really doesn't like artwork at all, and a person in this group that doesn't really like it at all. I'm going to assume that there's going to be somebody here that might be a professional artist, and there might be someone here with a professional artist, okay? So I want the groups to be sort of equivalent prior to imposing my manipulation for my experiment, okay? Now, from this brief description of this research, I'm going to assume, and I have faith in you, that you can generate a hypothesis and a null hypothesis for the question that we would be asking here. So let's do this. And if you would like, you can pause the video and see if you can write out the hypotheses and see if you're correct. So the null hypothesis in this case would say that the mean for the liking of the artwork for the population that gets no artist statement is going to be equal to the mean of the population that reads the artist statement prior to watching or prior to looking at the artwork. Now, notice that we don't have any number here to put in because this is original research. Nobody's done this really prior to my doing it, and so we don't have any reference number like we used before. We've weaned ourselves from needing to know any population parameters, and this is the standard kind of research process. There is another way to write this, though, and we could say that if we compare the two groups, and again, here's our mathematical function for comparison, and I want people to still embrace this, right? The math represents our thinking. It's not something different from it. I'm going to say, I'm going to compare this group to this group, use subtraction. And when I do that, there will be no difference. 0 for the difference, okay? So I trust that this is accessible to you folks, okay? Now the alternative hypothesis then would be that the group that doesn't get the artist statement will be different from, that is not equal to, the group that reads the artist statement. Okay? Alternatively, we could write that as, if we compare the two, there will be a difference. That is, the difference between the two will not be 0. Okay? So those are our two hypotheses, and that's a 0. I write both of these. I've seen textbooks that only use this, right, that only use these two. I've seen textbooks that only use this form. That's why I'm showing you both, okay? And sometimes students will ask, well, which one should we use? Well, hell, if I was the student at an exam, I understand both of these, and since the teacher wrote both of these, I would do the same thing. I mean, why wouldn't you show somebody that you really know this stuff, right? That you can do it in different forms. Okay, then step 2, of course, I'm going to use an alpha level of 0.05, sorry. 0.05. That's our standard level. That tells us what is the likelihood of making a type 1 error, and that's fairly low, 5%. I don't have any population parameters, and so I know I'm going to have to do a t-test here. If somebody gave me mu and sigma, then this would end up being a z-score. But we don't have that information, and so I'm going to have to do a t-test, and I'm going to get a critical t-value. I need to know the degrees of freedom to get the critical t-value. I don't have that yet. But I do know what the critical t-value will look like approximately. If you recall from our other discussions of the t-distribution, it's going to be about 2 point something, right? And that goes back to our ratio, difference over variability, difference over variability. The difference between the two has to be 2 times the variability. We'll get to that a little bit more afterwards. I know it's going to be plus or minus 2 point something. Take a look at the t-distribution in the back of your book, and you'll see what I'm talking about. Okay. So steps 1 and 2, not much different than what we've had before. This looks a little bit different, but that's because we now have 2 independent groups here that we're comparing one to another. So subjects come in, they get randomly assigned, half of them see the artwork without the artist statement, half of them see it after the artist statement. Let's look at the Likert scale ratings of how much they like the artwork, okay? So I'm going to keep them small. That's why I used a Likert scale here, because I want it to be easy for us to do this. I'm also going to use only 6 people per group, which is very small. It's really too small to do a publishable research project. But we're going to do it this way because we're going to do all of this stuff by hand. And because I want you to see where these numbers are coming from. I'll show you how to do it on a computer, and you can do the computations in under 30 seconds, okay? But once you get that number, if you don't know what it means or what things affect those numbers, then you really haven't learned anything, okay? So here are the 6 people that look at the artwork without an artist statement. Here are the 6 people that looked at the artwork with an artist statement. Now, the one thing you'll notice is there's variability. I mean, there's some numbers here that are bigger than some numbers here. But what I want to know is, on average, is this group higher than this group? Okay, on average. And so what am I going to do? I'm going to calculate the average. Okay, I'm going to make some room here. So you guys wrote these in your notes so we can refer back to them. But I'm going to take that away. I'm going to put my critical T up here. And in fact, we can now fill in the critical T. Well, let's wait on that actually, because I got to show you how to get the degrees of freedom here. Okay, so what I'm saying is, on average, is this group more than this group? So the first thing we're going to do is calculate the averages for these samples. You'll notice that this is an M, not a mu. And sometimes people are like, I thought we were, with our null hypothesis, an alternative, I thought those were mu's. Well, we will never know a mu value. But what we're saying is, these 6 people we hope represent that canvas bag, right? That hypothetical canvas bag. We're hoping that these represent the mu, that this sample mean is going to be close to the overall mean of all the samples, which is the same as the mu, okay? And so when we do this, let's see, 9 plus 9 is 18, plus 11 is 29, I think. 29 divided by 6. So we have a mean of 4.83. That's the average liking for the artwork if you don't read an artist statement beforehand. So let's look at the folks that did read the artist statement beforehand. You guys see what I'm doing here with this addition. 13 plus 17, that's 30, plus 12 is 42. Or you can slog along with your calculator, okay? And I might have made a mistake. 13 plus 17 is, what is it, 30? 13 plus 17 plus 12 equals 42 divided by 6. So this is the mean here is 7, okay? From these data then, I can see that there's a difference between the averages. There's an average difference. What I want to know is that big enough of a difference for us to make some kind of a conclusion, okay? So here's what we're going to do. We're going to use a t-test, okay? And the numerator of this t-test, I'm hoping just sort of makes sense. And boy, don't you hate that when a teacher says something like that? Well, I want to know if there's a difference between these averages. So listen, the numerator is going to be the difference between the means. Now I use 1 and 2 here instead of no and statement. That's because I'm developing here a generic formula for the t-test. Okay, so for any 2 groups, you subtract the first group, the second group from the first group. Doesn't matter which way you put these in. Okay, we're just looking at a difference here. Now, if you recall our single sample t-test, remember our single sample t-test had a mean, but we were given some population mean, right? So all we're doing here is replacing that with another mean. We're going to compare the 2 means. And then what we did was we had a measure of variability here. Right? And as you recall, it was S sub m. And the reason it was S is because we had to make a guess about what the variability was, an unbiased estimate, okay, because we weren't given sigma. Well, we're going to do a similar thing here, and this is going to be S with a subscript M1 minus M2. And I'm not going to make that bigger, folks. You know why? Because this is just a subscript. You're not doing any math here. It's just telling you this is an estimation of sigma, and then we do our central limit theorem step. If you need to review the single sample t-test, please do that, okay? Because knowing that will help you here, okay? It's the same notion as this variability. It's just telling us now we have 2 samples, okay? And in fact, remember, let's do this. You can check back in your notes for these formulas. This was our estimation for sigma. This is what my central limit theorem step. That's what goes in here, okay? We're going to do something very similar. The first step is this. I'm going to do an S with a subscript P. Take your time. The P stands for pooled. And this is pooled variability. Pooled variability. And this is going to be an S squared, okay? That's because we're not going to take the square root at this step. We're going to do the square root at this step. You'll see how this unfolds. I just want you to understand that this is really the same process as this. It's just that it's more complicated because we have two samples now. What do I mean by pooled variability? Very important concept. Did I say very important concept? Very important concept. We're going to get the sum of squares for the no statement group, and we're going to get the sum of squares for the statement group. That's going to be our start. And we're going to pool that together. It's just like if we pooled our money together to buy beer or something like that, right? If we pooled our money together, we're putting everybody's money together, right? This is pooled variability. What is it pooled from? It's pooled from two people or from two groups, okay? And here's what it looks like. It looks very much like this, except squared. So we're going to get the sum of squares for group 1 plus, because we're pooling it, the sum of squares for group 2, okay? We're going to divide by degrees of freedom for group 1 plus degrees of freedom for group 2, okay? So that's what we're going to do. That's the first step. That's equivalent to this step. This is going to be our guess for sigma. Remember, S is our guess, but this is squared, so this is going to be our guess for sigma squared. I don't want to get too caught up in that. We're going to take the square root later, okay? This is our guess for sigma based on the samples. This is our guess for sigma based on the samples. But we're going to pool the variability. But it's a single guess. It's a guess for one sigma. Okay? And sometimes people will say, aren't there two sigmas? And the answer is no. If you need to watch the previous video again, do it. Okay? What was our assumption? Well, if there's no treatment, if we fail to reject the null, then that means the groups came from the same population, so sigma's the same. And then somebody will say, well, what if we reject the null? If we say they're from two different populations? If we reject the null, what we're going to say is that the means of the populations are different. But the treatment just pushes the distribution up or down, right? Like this. Pushes it up or pushes it down. It doesn't change the variability. Okay? So there is only one variability. Here's how we're going to make our guess for the variability of the population. So let's get our sum of squares. First, remember our formula, okay? So let's do this quickly. I think we can do it, right? For the first group, 16 plus 25 plus 36 plus 9 plus 25 plus 36. Boy, it's nice to know your squares, right? So for the first group, it's 147 minus 29 squared divided by 6 So it's 140.16. Okay, so let's do this. 147 minus 140.16 equals 6.84. Okay, so this is 6.84. Now let's do the sum of squares for the second group. Okay, everybody with me? I'm going a little bit faster here because I'm assuming that you're good, because we've done this before. Okay, let's do the second one. 25 plus 64 plus 64 plus 81 plus 25 plus 49. Boy, it's good to know my squares. This is 308 minus 42 squared divided by 6. 294. Okay. So we have 308 minus 294 equals, and this sum of squares is 14. Okay? So we're going to put those together. $6.84 plus 14. Okay. Degrees of freedom for the first group. What's degrees of freedom there? N minus 1, right? So degrees of freedom for the first group is 5. Degrees of freedom for the second group, 6 minus 1. That's 5. Let's get this value. That's 20.84 divided by 10. 20.84 divided by 10 equals 2.084. All right. 2 decimal places is fine, but since I have it, I'll use it. This is the equivalent to our first step with our single sample t-test. Okay. That gives us our guess for sigma. Of course, we squared that. We didn't do any square root here, so that's squared. Now we're going to do this. We're going to do our central limit theorem step, and that is we're going to get S sub m minus m. That's just a subscript. That's not telling us to do anything, okay? It's just that we're comparing 2 groups instead of just 1. And that's going to be equal to, now we're going to square root everything. See, it's a little bit different form here, but that's because this is squared, so we put that in squared, and then we can square everything. Pooled variance divided by, now n for the first group plus n for the second group, okay? We have this value right here, folks, okay, right here. That's what that is, okay? Notice, by the way, here we have a line all the way across, so that means do this first, do this, and then divide it. Here it's separated, so we need to get this value divided by the sample size for 1, the same value divided by the sample size for number 2. You don't have to memorize these formulas, but you have to know how to use them, right? So here we have $2.084 divided by 6 plus 2.084 divided by 6. Let's do that. 2.084 divided by 6. And we add it again, 0.69. Under here, 0.69. Okay. Let me check to make sure that's right. 2.084 divided by 6. Okay, you do that twice. 0.69, let's call it 0.695. Okay. We're going to take the square root. now (0.83). Okay, so that ends up becoming this number. Everybody with me? Sum of squares for the first group plus sum of squares for the second, divided by degrees of freedom for the first, degrees of freedom for the second. Take this number, divided by n, 1, plus divided by n2, you get this value. Okay? That's what goes in here. Guess at S, central limit theorem, t-test. Our guess for S squared, central limit theorem, and our t-test. Thank God this is on video, right? It's great. Because instead of being in a classroom and I'm just like rattling this stuff off, you're like, what the hell's going on here? You can stop it, take a breath, you can rewind and look at it again, okay? And then we're going to subtract one mean from another. So we have 4.83 minus 7 divided by this value. So let's do it. Let's get our t. 4.83 minus 7 divided by 0.83. Our t value is negative 2.61. Okay. Now I'm going to ask you, what do you think we do with that? Well, we're going to compare, this is what we would call our observed t, right? I mean, this is what our research is showing us, okay? I want to compare that to my critical. Don't let this get away from you. This is just like when we had our z-scores and we were comparing it to 1.96, or when we had our single sample t-test and we were comparing it to a critical value. We're doing the same thing here, folks, the same thing, okay? But we got to know the degrees of freedom to get our critical t. Let me bring our t distribution up here again. Okay, this is from the table in the back of your book. As long as we know the degrees of freedom, then we can get our critical value. In this case, the degrees of freedom is the combined degrees of freedom, that is, degrees of freedom for each group, and then add them together. Here it is. Here's our little cheat sheet. Degrees of freedom for 1 plus degrees of freedom for 2. Our overall degrees of freedom are 10. If we go back to our data, I mean, the mistake here that sometimes people make is they think we're going to add this. There's 6 people here and 6 people here. That's 12 people minus 1. That's 11. That is incorrect to do that. Instead, what we're going to do is we're going to get degrees of freedom here, which is 5. Degrees of freedom here, which is 5. And then we'll add those together for 10. Okay? So, 10 degrees of freedom. I'm going to go over to the critical value. Critical value 2.201. I knew it was going to be 2 something. All right? Let's remember what this is. What this is it represents on our curve, okay? This number cuts off the extreme 5%. Alpha level, 5%. If our observed number goes beyond this critical value, then we reject the null, okay? And it doesn't matter if it's positive or negative. So, what we're going to say here is, I'm going to erase this. Make sure you do those computations. Make sure you do those computations. We'll do another example in the next video, but make sure you get these numbers. One of the things that people make a mistake with is that, you know, with our pooled variability, you got to add the sum of squares together and then add the degrees of freedom together, right? And do the division. For the other one, there's a separation here, so you do the two things separately for your central limit theorem. Okay, so this is bigger than our critical, and so we're going to reject the null. If you look back at the symbols, the null is saying that the two groups are equal. We're rejecting that. So we're saying that they're different. So we reject the null. I'm going to make my statement, and I'm going to say it appears that providing subjects, or let's get away from subjects, because providing, it appears that providing viewers, because I'm talking about people who are viewing the artwork, with an artist statement significantly increases. And sometimes people, I don't, well, it's a sign that people aren't thinking. It significantly increases. And people say, well, how do you know that it increases it? Well, look at here, folks. I mean, look. That's all. Just look. The average for the statement group is bigger than the average for the no statement group. If this is a Likert scale, where bigger numbers are indicating that people like the artwork more, then that's what we're seeing. Significantly increases liking for artwork. Again, and I'm just reinforcing this. This is not my opinion. This is not my opinion. It's my conclusion. It's not my opinion. It's based on these data. Okay? And when I did this research, I used many more subjects than 6 and 6, okay, to give me the most confidence that I can have. And so I'm going to put in my justification for making this statement, for making this conclusion. I have a justification. And the justification is the T with 10 degrees of freedom. And I'm going to report the observed T, folks. Don't report this. This is a reference number, okay? I'm going to report what I saw with my research. 2.61. I can put the negative in there if I want. We'll talk about that in a minute. And then P less than 0.05, period, after the parentheses. What I'm saying here is the probability that the null is true is less than 5%. I can't prove anything without a doubt, but I'm pretty sure the probability that the null is true is only 5%. Okay? Now, I put a negative here, negative 2.61. That's what we got. Oftentimes, when I'm doing a t-test, I just report it as a positive. And the reason for that is it's kind of arbitrary, because there's really no reason why I had to put the no artist statement group first and the statement group second. If I put these numbers over here, we would get a positive value. So in this particular case, it doesn't, really matter. It's almost like saying, am I taller than you or are you shorter than me? Right? Well, it depends on what number came first. Sometimes it does matter, sometimes it doesn't. In this case, I just don't see it mattering. For the purposes of our class, why don't we just retain the negative, because that's what we found. Okay? So this is a 2-sample t-test. And it is by far the more common t-test that people use. And now we have weaned ourselves from any kind of reference population, any kind of known values. And this is the procedure that you would use if you're doing a chemistry experiment, biology experiment, psychology, a criminal justice experiment, business study or whatever you're going to do, where you're comparing two groups. Okay, this is how it's done. So in the next video, we'll do another example. And by the way, I will show you these do not have to be equal sample sizes. So we're going to do one that has a different number of people in one group than the other group. And I'll show you the formulas stay exactly the same, but if you look back at your notes, the N1 and the N2 will be different, right? The degrees of freedom 1 and degrees of freedom 2 will be different. But we'll do an example where there's an unequal sample size for the two groups. Same procedure. So make sure you go through what we went through in this video. Make sure you have the same, you can generate the same values. You should have this value for your t-test. Okay. Again, like I say every time, email me if you have questions, and or we can Zoom or something like that. We'll take care of you. All right.